Hello, good morning. Experimental determination of transport number. The transport number of ion are usually determined by three methods: Hittorf methods, moving boundary methods, EMF measurement methods. First of all, Hittorf method. This method of determination of transport number is based on Hittorf's rule. Hittorf's rule states that the fall in concentration of ions around electrode is directly proportional to the transport number of ion moving away from it. Hittorf's rule states that the fall in concentration of ions around electrode is directly proportional to the transport number of ions moving away from it. The experimental setup of Hittorf's apparatus is shown in following figure. Apparatus and chemicals. Hittorf cell, silver nitrate solution, anode and cathode. This is the colorimeter, copper sulfate solution. This is the converter. In case of anode, silver releases electrons, and in case of cathode, silver gains the electrons. The experimental setup for determination of transference number by Hittorf's method. Hittorf's apparatus consists of two vertical glass tubes connected by a narrow U-tube in the middle. This is the U-tube. All the three glass tubes are provided with stop clock at the bottom to withdraw solution. Three tubes. This withdraw. We can withdraw from here in the tubes. The two side limbs are provided with electrodes which may be attackable. For example, silver or platinum. Two side limbs provide the electrodes which are attackable. Silver or platinum. In this apparatus, silver electrodes are used. All the tubes are filled with solution under study. The two side tube contain anode and cathode, which are anodic and cathodic compartment. The U-tube in the middle is called central compartment. This is the central compartment. Let we have to determine transport number of silver or nitrate. A standard silver nitrate is taken. The cell is connected to the series of battery and voltmeter for 2 to 3 hours. The tube is connected in series. This is the voltmeter, written colorimeter, and the voltage converter, AC/DC. Passing of current of 20 to 30 milliampere so as to produce appreciable change but not large change. Appreciable change, not large change. After electrolysis, the solution are withdrawn from each compartment, weighed and analyzed. After electrolysis, the solution is withdrawn from its compartment and weighed. There should be no change in the concentration of solution taken from central compartment. The weight of silver deposited on the cathode voltameter is accurately determined. Calculation is first when electrodes are unattackable. Platinum electrodes are used. After electrolysis, let the weight of anodic solution taken after electrolysis, a gram. The amount of solute present in a gram solution is the B gram. Weight of solvent, A minus B gram. A minus B gram of solvent contain B gram of silver nitrate solute. That is B over 170 gram equivalent of silver nitrate equal to B over 170 gram of equivalent of silver equal to Y gram equivalent of silver. Before electrolysis, weight of anodic solution taken before electrolysis, C gram, fall in concentration, C minus B gram. So C minus B over 170 gram equivalent of silver nitrate. Let weight of silver deposited in silver colorimeter be W1 gram equal to W1 over 108 gram equivalent of silver equal to W gram equivalent of weight of silver. Transport number of silver TAG equal to fall in concentration anode in gram equivalent over amount of silver deposited in gram equivalent. TAG equal to D over W and transport number of NO3 nitrate TNO3 equal to 1 minus D over W. Case second, when electrodes are attackable, silver electrodes are used, increase in concentration of anodic solution, B minus C gram of silver nitrate. So B minus C over 170 into 110, 8 gram of silver equal to B minus C 170 gram equivalent weight of the silver. If number of silver ions has migrated from anode, the increase in concentration of silver ions would have been equal to W. Fall in concentration due to migration of silver ions, W minus E, hence transport number of silver ion, TAG plus equal to W minus E over W, and transport number of NO3, TNO3 equal to 1 minus W minus E over W. Okay, it's all about Hittorf's methods for experimental determination of transport number. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.